If you use LLMs for coding, you've almost certainly run into a predictable set of frustrations. Instead of asking for clarification on an ambiguous prompt, the model makes a silent assumption and runs with it. Instead of writing a simple function, it builds a massive speculative abstraction you didn't ask for. And when you ask it to fix a single bug, it decides to reformat half the file, changing variables and stripping out dead code along the way. Andre Karpathy, a founding member of OpenAI and former head of AI at Tesla, zeroed in on these specific behaviors as the core problems. Based on his observations, developer Forrest Chang built a framework to solve them. It's called the Karpathy Skills plugin. To implement this fix, you need to have an active instance of Claude code installed on your machine and a terminal window open. Applying these new rules completely changes the dynamic. It takes an automated tool programmed to blindly generate output and turns it into a deliberate agent that evaluates a problem before it starts typing. The plugin operates on 4 distinct principles. The first is think before coding. This rule requires Claude to explicitly state its interpretations of your prompt. If a task is ambiguous, the model must outline the potential trade-offs and ask you clarifying questions to ensure it understands the exact goal before it writes a single line of code. The second principle is simplicity first. This places an absolute ban on over-engineering. The model is instructed to write only the minimum viable code required for the task. No single-use abstractions, no complex configuration layers, and zero future-proofing for features that might be needed later. Third is surgical changes. If you ask Claude to fix a bug on line 42, it is strictly forbidden from touching line 43. It cannot reformat adjacent blocks, it cannot rename working variables, and it will not update your import ordering. Every unrelated change is treated as noise. The fourth principle is goal-driven execution. Instead of giving the model a list of imperative commands to execute, you assign it a declarative outcome paired with a way to check its own work. For example, rather than saying, "Fix the login bug," you tell the model that the login page needs to accept valid credentials, and you instruct it to verify that by running your test suite. The model then enters an independent loop. It implements the code, runs the test, and if the test fails, it knows the job isn't done. Tying the prompt to a verifiable test means the model cannot declare the task complete just because it feels confident in what it wrote. The code has to actually pass the objective standard you set. To get these principles running, you have 2 deployment options: a universal, machine-wide installation or a local, per-project installation. For the global setup, you simply go to your terminal and enter the installation command for the Karpathy Skills plugin directly from the Claude Code Marketplace. When the command executes, your terminal will output a clear success message and display an active status indicator, confirming the rules are now running in the background. The main limitation of this approach is its rigidity. Once installed globally, the framework applies exactly the same way to every workspace on your machine, making it difficult to adjust the rules for specific repositories. Even so, this method establishes an immediate, universal safety net across all your development work, shutting down assumption-prone, reactive coding by default. The second method is the local installation. To set this up, navigate into your specific project directory in the terminal and execute a curl command to download the text file directly. This places a single file named claude.md straight into the root folder of your project environment. If you already use a custom file for Claude in your repository, do not overwrite it. You need to copy and append the new Karpathy guidelines to your existing rule set. The primary advantage of keeping the rules in a local markdown file is that it can be checked into your project's version control. When other developers pull down the repo, they get the exact same AI guidelines. It also means you can easily customize the behavior. You can append domain-specific logic, language-specific formatting preferences, or strict architectural guidelines directly beneath the base Karpathy rules without causing system conflicts. This local approach scales the framework up from an individual developer's preference into a synchronized, project-wide standard that every contributor uses. To verify that these principles actually alter the model's behavior, developer Jawan Zhang ran an experiment. He instructed Claude to use the Karpathy framework to review its own generated guidelines. The starting point was 800 lines of speculative complexity. Applying the simplicity first rule, the model aggressively cut down the document, stripping instructions to their absolute core. The final output landed at just 70 lines, reducing overall complexity by 91%. By explicitly defining the parameters for simplicity, the prompt forces the model to edit out the bias toward over-engineering that it learned during its initial training. With the framework installed, your coding assistant changes. It pushes back on vague requests, highlights inconsistencies in your logic, and forces you to clarify ambiguities. Open your code editor right now and ask Claude to add a simple new feature. You will notice the delayed, methodical execution as it plans the path forward before writing anything. The downstream result of this process is that the diffs produced by the model are isolated and precise. This yields clean pull requests that contain exactly what was asked for and nothing else. Producing consistently high-quality AI code does not require waiting for the next generation of models to be released. It requires establishing strict, explicit rules of engagement for the models we already have.